This lesson is a continuation from the last lesson where we learned how to add and subtract signed numbers. In this lesson, we will learn how to multiply and divide signed numbers, and we will examine the topics of order of operation and absolute value. Let's begin with multiplying and dividing signed numbers. Now, the rules for multiplying signed numbers are the same as the rules for dividing signed numbers. They are as follows. When two positive numbers are multiplied or divided, the result will always be positive. When two numbers are multiplied or divided, when one number is positive and the other number is negative, the result will be negative. And when two negative numbers are multiplied or divided, the result will be positive. Now, these rules can be summarized as follows. If we are multiplying or dividing numbers with like signs, that is, they are both positive or both negative, the result will be positive. And if we are multiplying or dividing numbers with different signs, that is, one is positive and the other is negative, the result will be negative. Now, once we use these rules to determine whether a result will be positive or negative, we then ignore the signs to find the product or quotient. So, for example, here we are multiplying -2 and +3. Since the two numbers have different signs, the product will be negative. Once we know that the result will be negative, we ignore the signs and multiply 2 and 3 to get 6. So -2 times +3 will equal -6. In this next example, the two numbers have the same sign, so the result will be positive. Once we know that the result will be positive, we ignore the signs of the two numbers and find the product of 5 and 6, which is 30. So -5 times -6 equals +30. Now, for products where there are more than two numbers, we must work with pairs of numbers. So first we have 4 times -10. Since their signs are different, the result will be negative, which means 4 times -10 equals -40. Next, we will multiply the result with -2. Since their signs are the same, the result will be positive, which means -40 times -2 equals +80. So the product of all three numbers here is +80. Now, another way to tackle products with more than two numbers is to first find the sign of the entire product and then find the number part. So first, the product of these two numbers will be negative since their signs are different. Then, when we multiply this negative result with +3, the result is still negative. And when we multiply this negative result with +4, the result is still negative. So we now know that the product will be negative. At this point, we can ignore the signs and multiply the four numbers to get 24. So -1 times 2 times 3 times 4 is equal to -24. All right, now let's tackle some division questions. The same rules apply here, so since these two numbers have the same sign, the quotient will be positive. And once we know that the result will be positive, we can ignore the signs and divide 12 by 4 to get 3. So -12 divided by -4 equals +3. In this next example, the two signs are different, so the result will be negative. So 15 divided by -3 will equal -5. Also note that we can express division as a fraction, so this is the same as -60 divided by 6. Since the two signs here are different, the result will be negative. So -60 divided by 6 will be equal to -10. Now that we have examined how to add, subtract, multiply, and divide signed numbers, let's see what happens when we combine operations. Notice that there are two different ways we could evaluate this. If we first add the 2 and 3 to get 5, and then multiply 5 by 4, we get 20. Or if we first multiply the 3 and 4 to get 12 and add this to 2, we get 14. So which of these two answers is correct? Well, the second answer is correct because it follows the rules that dictate the order in which we must evaluate expressions when there are two or more operations involved. Now, there are two popular sets of rules regarding order of operations. One goes by the acronym PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. The other goes by the acronym BEDMAS, which stands for brackets, exponents, division, multiplication, addition, and subtraction. Now both of these show the hierarchy of operations, and although they look different, they both specify the same rules. At the very top we have parentheses, also known as brackets. This means we must always evaluate the information inside any parentheses first. Once we have evaluated any parentheses, we must then evaluate any exponents. Next we have what looks like a problem. On the left-hand side it looks like multiplication comes before division, and on the right-hand side it looks like division comes before multiplication. Well, this is the problem with displaying PEMDAS and BEDMAS like this. In actuality, multiplication and division are on the same level of the hierarchy. Likewise, addition and subtraction are also on the same level. So a better way to display these rules are as follows, with multiplication and division on the same level, and addition and subtraction on the same level. This means that if we have both division and multiplication in an expression, both operations are considered equal, so we must tackle them in order from left to right. The same applies to addition and subtraction. If addition and subtraction both appear in an expression, both operations are considered equal, so we must tackle them in order from left to right. Alright, let's try some questions. Here the operations are subtraction, addition, and exponent. According to our order of operations, we must evaluate the exponent first. Since 5 to the power of 2 is equal to 25, we can replace 5 to the power of 2 with 25. Now that we have taken care of the exponent, we have two operations remaining, addition and subtraction. Since addition and subtraction have the same level of importance, we must tackle them from left to right. So first we have 6 minus 2, which equals 4. Next, 4 plus 25 equals 29, so the entire expression evaluates to be 29. Alright, let's try another one. According to PEMDAS, our first step must be to evaluate what's inside the parentheses. Now within these parentheses we have subtraction and multiplication. Since multiplication ranks higher than subtraction, we must tackle this first. So 3 times 5 is 15, so we can replace 3 times 5 with 15 over here. Since we still have parentheses, our next step is to evaluate 10 minus 15, which equals negative 5. At this point, our two remaining operations are addition and subtraction. Since addition and subtraction have the same level of importance, we must tackle them from left to right. So first we have negative 2 plus negative 5, which equals negative 7. And finally, negative 7 minus negative 7 is equal to 0. Now before we end this lesson, I want to cover one last topic, which is absolute value. The lines on either side of x here represent absolute value, and this particular expression is read as the absolute value of x. Now the absolute value of a number is the number's distance from 0 on the number line. So for example, to evaluate the absolute value of negative 4, we can first sketch the number line and then see that negative 4 is 4 units away from 0. As such, the absolute value of negative 4 is 4. Similarly, to evaluate the absolute value of 3, we locate 3 on the number line and then recognize that 3 is 3 units away from 0. As such, the absolute value of 3 is 3. As you might guess, the absolute value of a number is simply the positive version of that number. So we can say that the absolute value of any non-zero number is always positive. Alright, let's summarize. In this lesson, we learned how to multiply and divide signed numbers. We learned the order in which operations must be evaluated, and we learned about absolute value. In this lesson, we will take an introductory look at decimals such as the ones shown here. In doing so, we will examine topics such as place values, operations with decimals, and rounding. Now to begin, we should recognize that whenever we write a number, we are essentially creating a recipe for expressing some value. For example, in the number 743, the digits 7, 4, and 3 are in the places that represent hundreds, tens, and ones. The 7 in the 100s position tells us our number consists of 7 100s, or 7 times 100. The 4 in the tens position tells us our number consists of 4 tens, and the 3 in the ones position tells us our number consists of 3 ones. So the number 743 represents the value of the following sum. Decimal notation is just an extension of this. So here the 8 and 2 represent 8 tens and 2 ones. Continuing in a similar manner, the digits to the right of the decimal represent fractional powers of 10. So the first digit to the right of the decimal represents tenths, so the 7 in this position tells us our number consists of 7 tenths. Similarly, since the 4 here is in the 100th position, our number consists of 4 100ths. And since this 3 is in the 1000th position, our number consists of 3 1000ths. So the value of the number 82.743 is equal to the sum on the right-hand side. Alright, now let's take a closer look at the place values to the right of the decimal. The first digit represents tenths. The second digit represents hundredths. The third digit represents thousandths, and so on. Now, an important feature of decimal notation is that if you take a decimal and add zeros to the last digit after the decimal place, the value of the number does not change. Here's why. If, for example, we examine the number 5.32, we see that it represents the sum of 5 ones, 3 tenths, and 2 100ths. Now, if we add 2 zeros to the end of this, all we are doing is adding 0 thousandths and 0 10,000ths to the sum, and this will have no effect on the value of the number. Alright, that's how place values work. Now let's examine how to perform operations on decimals, beginning with addition and subtraction. Now to add and subtract decimals, the rule is to line up the decimals and add any required zeros to the end before adding or subtracting. So for example, to find this sum, we first line up the decimals vertically. Then, to make it easier to add our digits, we might add some extra zeros here. And at this point, we can add the digits, being sure to keep the decimal place in the same location. Now the rule for subtraction is the same. To perform this subtraction, we first line up the decimals, and then we add any necessary zeros to make our calculations easier. At this point, we subtract while keeping the decimal in the same location. Alright, now let's examine multiplication. For multiplication, we should first count the total number of digits that are to the right of each decimal. Then ignore the decimals and find the product. And once we have a product, we take the decimal place and move it to the left based on the total number of digits that were originally to the right of each decimal. Alright, let's now apply this to the following product. First, observe that there is a total of 4 digits to the right of the decimals. At this point, we can ignore the decimals and find the product. Now at the moment, the decimal place is right here. Since we originally had a total of 4 digits to the right of our decimals, we must now move this decimal place 4 spaces to the left, 1, 2, 3, 4, to get the following product. Alright, now let's look at how to divide decimals. The steps here are as follows. First, move both decimals until the divisor becomes an integer. Then divide and keep the decimal in the same location. So to divide these numbers, let's first rewrite the division this way. Now before we can divide, we must take our divisor here and turn it into an integer by moving the decimal 2 spaces to the right to get 285. Now since we moved the decimal in the divisor 2 spaces to the right, we must also take the dividend and move the decimal 2 spaces to the right to get the following number. At this point, we are ready to divide 285 into 4,354.8. First, 285 divides into 435 one time, and we will now multiply 285 by 1 to get 285. At this point, we will subtract this from 435 to get 150. From here, we will drop this 4 down and continue. Next, 285 divides into 1,504 5 times, so now we'll multiply 285 by 5 to get the following, which we will subtract from 1,504 to get 79. From here, we'll drop this 8 down and continue. 285 divides into 798 2 times, and 285 times 2 gives us 570, which we subtract to get 228. At this point, we must continue to divide until we are left with no remainder. So let's add a 0 to the end of this number and then drop it down here. Next, 285 divides into 2280 8 times, and 8 times 285 gives us 2280, which we subtract to get 0. At this point, we have a remainder of 0, which means we are done. The quotient is 15.28. Okay, the last topic we will examine is rounding decimals. To set this up, let's first remind ourselves of the place values. Now, when it comes to rounding numbers to a certain place value, we must first go to that place value and then examine the next digit that lies to the right of that place value. If that next digit is 0, 1, 2, 3, or 4, then we will round the number down, and if the next number is 5, 6, 7, 8, or 9, then we will round the number up. Here's what I mean. If we want to round this number to the nearest tenth, then we first locate the digit in the 10th position. Here the digit is 3. Now, since the digit to the right of 3 is an 8, we are going to round the 3 up to a 4 to get 7.4. Similarly, if we want to take this number and round it to the nearest thousandth, we first locate the digit in the thousandth position and then examine the digit to the right of it. Since this digit is a 1, we must round our number down to 15.023. Okay, let's try one more. To round this number to the nearest hundredth, we first locate the digit in the hundredths place and then examine the digit to the right of it. Since the next digit is a 5, we must round our number up to 0.37. Okay, let's summarize. In this lesson, we learned the place values of decimals, we learned how to perform operations on decimals, and we learned how to round decimals.